I got your doubt. This is your answer.
Vedantu. Learn live online. To attend a free live class, download the app.
Hello everyone. Good evening. Hi Sunanda, Sara, Satyam, Nitesh, Pushpa, Anukriti. So tell me, how are you all doing? All doing fine, awesome. I can't see that excitement in the chat. Where are you all? Are you all there? Say yes or no. Excited for today's class? Okay, where are others, Rex? I can't see that kind of josh which I had in the yesterday's class. Hi Pushpa, Chaitanya, Durga, Neetu, Preet. So nobody have told me how you all doing. It's time to say, because we have a big thing to discuss about. I'm all good, Banu. Thank you for asking. Usually I don't get that question. Great, awesome, right? So I hope you all are doing so great in this exam days, right? Or you can say it as study days. Yes. Now the chat is active. I want this if I want to have a very beautiful class, right? So before starting with the class, just one thing I have to tell you guys, please take care of your health and have a proper sleep at least for 6 hours, okay? Then only you will be able to write a proper examination. So you must be knowing how important the health is on the exam day, right? So for those who don't know me, myself Ameer Basit, master teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay, I'm doing good. I'm doing all good. Thank you for asking. Banu, Nidesh, Rahul, Jay, Nidesh. So many names I can see. So I hope you all are comfortable. And here we are with another MCQ series so that you'll get full marks in the objective questions which is coming in the CBSE board exams, right? Okay, so which chapter we are going to discuss about? Again, moving charges and magnetism and matter, right? Because yesterday we did only some questions only. So today we are going to do more amount of questions so that you can be more thorough about the topic, right? All good? All happy? So what I have to tell you before starting with the session, so if you guys are having any trouble with the theory of any chapters, go to the Vedantu side, which means come to our Vedantu side, and whatever micro courses, whichever chapter you're having difficulty, buy that for how much of rupees? Just 1 rupees, okay? How much you have to pay? Just 1 rupees. Hi. हिंदी में बात करने के लिए मुझे नहीं आता है पुकुल. Okay, yes, I'm from Kerala. So just because of that, I'm not so much familiar in which language? Hindi. So I'll try to learn. Okay. So shall we start? All ready for the MCQ series? All ready or what? Huh? Everyone with me with the first question. So you can also answer in the chat box. Oh, I'll also be looking into it. All good? Hi Sanju. So first question. In a permanent magnet at room temperature. So when you talk about permanent magnet, what kind of magnet it is? It is a ferromagnet, right? In a ferromagnet, all the atoms in a ferromagnets have electric dipole moment, and what it forms? The atoms which are having the dipole moment in the same direction will form a group, right? That group is called as domains. So in a ferromagnet you can see many domains, right? And if it is kept at a neutral temperature or in a room temperature, most of the domains will be oriented in the same direction to give it a net value of dipole moment, but some of it will be randomly oriented, right? So which option we can go for this particular thing? Okay, so I hope now you can see the slide. I'm sorry for covering the slide. So which one? They are not perfectly aligned because we are not giving any external magnetic field, right? So the domains will be partially aligned. Okay, some of the domains will be aligned in the same direction. If I can draw it, okay, so look, if this is the ferromagnet, some of the domains will be aligned in the same direction, okay, in order to give a net dipole moment, because it is a permanent magnet. As we are not giving any external magnetic field, some of the domains will be randomly oriented like this, okay? So what can I say for this particular question? Domains are partially aligned, right? Understood, I hope. So not that difficult. Everyone happy? Say yes or no. Yes, good. Next one. A 25 centimeter long solenoid has radius 2 centimeters, okay, 500 total number of turns. It carries a current of 15 ampere, okay. So if it's equivalent to a magnet, you know that a current carrying solenoid is equivalent to a magnetic dipole of the same size. And what will be the magnetization of that equivalent dipole will be, or magnetic dipole will be? What is the formula for magnetization or intensity of magnetization? Who is going to give me the answer very fast? Who is going to give me the answer for magnetization or intensity of magnetization? Nobody there? Yuvika, Sanchu, Satyam? Who is going to give me the answer or the formula for magnetization? Nobody is giving me, so it's fine. So let me write it by myself. So intensity of magnetization will be equal to, what is it? Net dipole moment, magnetic field divided by, okay, or if you want, I am going to write it as B the one minute. So that is equal to magnetic dipole moment. Okay, so I'm writing it with M divided by V. Okay, so what is the formula? Intensity of magnetization is equal to magnetic dipole moment divided by volume. So what is the formula for magnetic dipole moment? What is the formula for magnetic dipole moment? Number of turns into current into area divided by volume can be written as, how much will you write? Area into length. If you cancel both the areas, what will you get? Ni divided by L. Okay, what is N? Number of turns is equal to 500, right? What is the current value I? It is 15, and length is equal to 25 centimeters. That is 25 into 10 power minus 2. So who is that good in calculation? 500 into 15 into 25 into 10 power minus 2. How much will you be getting? You will be getting the answer as 3 into 10 power 4 ampere meter inverse. Okay, so we can go for the option D. All good, happy, understood, clear till here? So next one, the fourth question, Curie temperature is the temperature above which, what is it? What is happening? You know that in the case of ferromagnets, if we increase the temperature, its magnetization decreases, right? So if you go on increasing the temperature, its magnetization decreases, and the ferromagnet will be converted into a lower powerful magnet, which is called as paramagnet. Okay, and the temperature at which that happens is called as Curie temperature, right? So Curie temperature is the temperature above which a ferromagnetic material becomes what? A ferromagnetic material becomes a paramagnetic. So which option we should be going for? We should be going for the option A, right? So guys, I hope now you can see the slide, right? Good. So where is our next one? Yes, so the material, next one, very good. So keep the class this much excited till the end of it, right? I'll be so happy. Now we have another question to discuss. What is it? The material suitable for making electromagnets. What are electromagnets? Electromagnets mean temporary magnets, which mean whenever we want it or whenever we give the external field, it should be acting as a magnet. When we take it away, it should be acting as a normal object, or the magnetism should be avoided, right? Okay, so what should be its retentivity and what should be its coercivity, right? What do you mean by retentivity? The amount of magnetism present in the material, though we remove the external field, is called as retentivity. So in the case of electromagnets, for safety purposes, if due to some reasons, if the external field is gone also, due to safety reasons, some amount of magnetic field should be retained in the electromagnets, right? So it should be having high retentivity. But that retention of the magnet should be taken away if we can give a field in the opposite direction, which is of low value, right? And you might be knowing what is coercivity. What is coercivity? The amount of external magnetic field that must be given to the magnetic material to cancel its magnetic field is called as coercivity. And here what I have told you, the external field should be very low that I have to give to cancel it. So the coercivity should be low. So which one? It should have high retentivity and low coercivity. So which option says you that? Guys, tell me which option tell you that? For the electromagnet, it should be having high retentivity and low coercivity, right? Yes, so the amount which is used to demagnetize is called as coercivity. Good, happy, everyone, clear? Next one, angle of dip is 90 degree at. Okay, very good, very good, very good. So now the chart is active. So what do you mean by angle of dip? Angle of dip is the angle made by the net magnetic field with the horizontal, right? So if I draw the figure of the earth, look, now the earth is over here, right? Okay, how the magnet is present? You know that there is a magnet, or we are assuming that there is a magnet present well at the center of the earth. Okay, so at the north pole here you have the south and north over here. This is how the magnet is present inside the earth, or we assume that a bar magnet is present, right? Okay, so when you take a needle over here, okay, how will it be? It will be exactly pointed downwards like this, right? And what is the horizontal? This is the horizontal now, right? So what is the angle that it makes? It is 90. Where is the angle of dip is 90 now? What position you call this as? This is called as poles, right? So at the poles, angle of dip is 90 degree, right? Understood everyone? Good, happy? Where is our next one? Yes. So look, read the question. Two identical bar magnets are fixed with their centers at a distance small d apart, right? Good. Banu, Sara, Nitesh, Isra, I hope everyone is able to understand, right? Sanchu? So what is happening? So now they are kept at a distance of small d apart. A stationary charge Q, capital Q, is placed at P. I hope you can see where the P is, right? At point P, in between the gap of the magnets, at a distance of capital D from the center O as shown in the figure, right? Okay. The force on the charge Q is, what is the force? Or what will be the direction of the force? Who is going to tell me this? Is anybody there who is so brilliant out there to give me the answer? It's a simple question only, but you just have to use your common sense so that you can answer it. So where you are keeping the charge is kept in a place where there is a magnetic field, right? Okay, you know that the force experienced by a charge in a magnetic field is equal to QVB. Okay, where velocity is there. Now the charge is at rest. So what is the force experienced by a stationary charge? What is it? Very good, awesome. It is option A, which is 0. So it experiences no force. Very good, awesome kids. Now next one. The vertical component of Earth's magnetic field at a place is √3 times the horizontal component. Let's write it. Okay, so if you want, we can draw it also. It will be better for you to understand. So think that this is the net value of magnetic field, B net. I hope everyone can see this. So if I take the component, this will be B horizontal and this will be B vertical, right? And the angle that it makes with the horizontal is called as what? Angle of dip or theta. Good, clear till here? Now what is said in the question? The vertical component, that is BV, is equal to √3 times B horizontal, or BV by BH is equal to √3, right? That's what we got now. Now the question is the value of angle of dip. What is the value of this theta angle? How will you find out? Look into the figure. What can you take? Tan theta is equal to opposite by adjacent, which is equal to BV divided by BH. We already have the value from here. What is BV by BH? √3. All my kids know that, right? So tan theta is equal to √3. So theta is equal to how much? How much is it? Very good, very good. Now many people like Anumol, Sanchu, Preet, Shivi, Anukriti, Gagan, everyone already gave me the answers. Yuvika, Harpreet, Nitesh. Wow, wow, wow. Guys, you don't have to worry at all. You're going to score a lot much marks in the coming board exams, okay? So have that self-confidence, trust yourself. Next, it's a simple question. Magnetic moment, B is the magnetic field intensity. Torque is given by, what is it? What is the value for torque given in this question? Yes, good, good, good. What is the value for torque given? Let me see. Anmol, Ritu, Nitesh, Bhavya, Sunanda, wow, wow, wow. Now everyone is giving me the answers. The value is what? The torque experienced by a magnetic dipole in an external magnetic field is equal to M cross B. Can I ask you a single question to you, which is not there in the slide? What is the net force experienced by a dipole in a uniform magnetic field? What is it? Who is going to give me the answer for that? What is the net value of force experienced by a magnetic dipole in an external magnetic field? What is it? Guys, nobody there to give me the answer for this, what I have asked you? It is 0 only, right? Because it will be experiencing equal and opposite forces, right? Yes, very good. Sarah was telling it is 0, right? Because it will be experiencing equal and opposite forces. But how the torque is produced? Because equal and opposite forces will act as a couple and will rotate this, right? Good. Okay, I can see that 0, 0, 0 in the chat box. I'm so happy for that. Very good. Next, the correct plot. Very good, very good, very good. Next one, listen here. The correct plot for the magnitude of the magnetic field versus distance from the center of wire is, if the radius of the wire is r. Okay, everyone knows, if you know look, I'll draw the figure. So think that this is the wire, okay, current of I is moving. You know that if the point is at a distance of r from the axis of this wire, everyone knows the formula for magnetic field. What is the formula? B is equal to mu naught divided by 4 pi 2I divided by r, right? If the point is outside the wire, right? Which means if the value of the distance is greater than the radius, it is inversely proportional to r. B is inversely proportional to r from the radius. Okay, after the radius, how will it is? It is inversely. So from r, how it should be? It is inversely proportional, this graph. Now, you have to tell me what is the formula for magnetic field if the point is inside the wire. Anybody knows the formula? Do anyone knows the formula to find out this? Is equal to how much? Anyone knows? So magnetic field in that case is equal to mu naught J R divided by 2, right? So mu naught J R divided by 2, where J is the current intensity, right? So here, from here, what can you understand? What can you understand from here? From here, it is well clear that the magnetic field is directly proportional to r if the distance of the point is inside the radius. So how will it be? It is directly proportional till it reaches the radius, and after that it is inversely proportional. So which option we can go for? Which option we can go for? We can go for the option B, right? Okay, someone is asking what is J? J is called as the current density or current per unit area, or if you want to write, J is equal to I divided by pi r square. Okay, current density, I hope everyone knows this, right? From the chapter current electricity, J is equal to I divided by pi r square. If you want, you can substitute over here I divided by pi capital R square also. Good. Everyone happy? Someone told me that he haven't understood. What about others? Anybody is having doubts or all clear? Everyone clear till here? Anybody is having doubt? Let me know. Circle. Huh. So done, right? Shall we move to next one? Yes. Good. Very good. Where is our next one? Okay. A charged particle is moving in a cyclotron, right? Okay. What effect on the radius of the path of this charged particle will occur when the frequency of ratio of frequency is doubled? Okay. When the frequency is doubled, what will happen to the radius? What is the formula for radius? R is equal to mv divided by qb, right? Radius is equal to mv divided by qb. Is there a thing like frequency coming in this particular equation? Can you see frequency in the equation? No, right? So as you cannot see frequency is there, so though if we change the frequency, what will not be changing? The radius is not gonna change, right? So as the radius is not going to change, which option we should be going for? We should be going for the option D, right? So it will remain unchanged is our option. Good. Happy with this? Next, and let it be the last question of the session. So what does it say? Okay, a charged particle is moving on a circular path with velocity v in a uniform magnetic field B. Okay, if the velocity of the charged particle is doubled, velocity is doubled and the strength of the magnetic field is halved, then radius becomes what? What is the formula for radius? Who can tell me that? Who can tell me that? What will be the value of radius? How much more it will become? Same, right? I have already written the formula for radius. What is the formula for radius? R is equal to mv divided by qb, right? So r dash, let's see what is the new change in r. Okay, in the second case, what is happening? Velocity of the charge is doubled. So m into, instead of v, 2v, q into field is halved, right? So it becomes b by 2, right? 2 goes up, so into 2. So this is equal to 4 mv by qb. 4 times mv by qb is equal to r. So which one? Which option? It is 4 times, right? So I hope everyone have understood that and cleared till that. So guys, clear? So what I want to tell you at this moment of time is that you might have understood this. If you still is having any doubts regarding the theory of any chapters, I have already done a series regarding that. Okay, it is still available in the YouTube. You can type my name, which is Ameer, okay, and type the required topic. You will get a previous year question paper discussion also, which will be there for 1 hour, and the theoretical explanation also. Okay, it will be more helpful for you and you will be much more benefited in that, right? So guys, I hope you all have understood about today's class, right? So if you have understood and if you think that my teaching was good and likable, please put the or press the like button. And if you think that your friends also require this, they will also be benefited, don't forget to click on the share button. Then come the third one, okay, where we both will be benefited. Okay, I'll be benefited in such a way that I'll get to know that you guys are getting interested, you guys are understanding my things, and it will also be a motivation for me to do more and more videos for you and for the younger generation which is coming to 11th and 12th, right? So that is how I'm benefited and how you're benefited by putting the subscribe button, because you will be getting the notification of all the videos which is getting uploaded by JEE channel, right? Because after the board exam, JEE series will be starting, how to prepare for JEE and all those stuffs. Okay, if you want to get it at the right time, please press on the subscribe button. So let's not waste our time, move your cursor and just push that subscribe button now itself. Okay, so next class at 6:30 till Saturday we'll be having the classes, right? Okay, thank you so much. Till we meet next time, everyone take care and study well. Okay, so bye.